Hello and welcome. We're at the top of the hour, so we'll go ahead and get started with our webinar. My name is Melanie Ross, and I will be your facilitator and co-presenter for our webinar today. Our presenter is Deanne Emory. Thank you for joining ANAB for our complimentary webinar on method validation of modified standard methods. Please note that we are recording this webinar, so it will be available for future viewing. Some logistics before we get started. Due to the number of attendees, everyone will remain muted during the duration of the webinar. Please enter your questions into the QA box. We have planned time at the end of the webinar to answer any questions asked. Just a little bit about our presenters today. Deanne Emory will be our main presenter. She is an instructional designer at ANAB. She has over 30 years of experience in quality assurance and quality management in both laboratories and manufacturing. Currently, her role at ANAB is to develop and instruct training courses and assist with training of ANAB's contract instructors. I'm Melanie Ross, and I'm a technical products developer with ANAB. I have over 20 years of experience in quality control, quality assurance, and quality management in a variety of industries. My current role is to develop technical products such as these training courses, webinars, blog posts, and conference talks. Today we are going to discuss when laboratories may need to supplement international, regional, or national methods and give an overview of techniques for validating a standard method used outside its scope or otherwise modified. We are going to use the ASTM test method model as the example of a standard method. During the presentation, we will highlight the importance of method validation for ensuring the validity of results of measurements in the laboratory. Before we start discussing modifying standard methods, let's define what a standard method is. There's a lot of different ways to define a standard method, and 4 of those ways are on this slide. A standard method can be a way to describe in detail the method of a measurement to determine specific properties or performance characteristics of a material or product. In more simpler terms, it's a method that describes and standardizes to define a measurand. It can also be a method can also break down work into elements or operations, which are sequenced, organized, and repeatedly followed. And finally, a standard method is officially accepted and recognized. It is described in unambiguous details and validated for a standard purpose or scope. There are many different sources of standard methods. Here are just 4 examples of sources of standard methods. You probably have other examples as well. ISO is the International Organization for Standardization. AOAC is the Association of Official Analytical Chemists. ASTM International is formerly known as the American Society for Testing and Materials. And the US EPA is the United States Environmental Protection Agency. Again, during our webinar today, we are going to use the ASTM test method as our model for standard methods. With that, I'm going to turn the control over to Deanne and let her get into the creation of standard methods at ASTM. Deanne, the ball is yours.
Thank you, Melanie. ASTM technical committees will evaluate requests for needed standards to ensure they are market relevant, non-duplicative of existing standards, and have sufficient community support for development. Once the decision is made, a project is initiated and a task group is formed to draft the standard. Once the task group has reviewed and agreed on the draft, it is sent to the sponsoring subcommittee for voting. This will likely elicit technical negatives and comments. This phase of balloting may take several rounds, and eventually it will go to the entire committee for voting. Once again, any negatives will need to be addressed and comments discussed. Near the end of final voting, the standard will also be sent for review by the entire society. If the standard is a test method, as we are discussing today, there may also be interlaboratory comparisons that need to be done to develop the precision and bias statements. There may also be measurement uncertainty requirements developed, reporting requirements, as well as any quality control methods that the standard may need. Once the standard is ready, it will be reviewed by the ASTM editors and by the ASTM Committee on Standards. It is then published. The ASTM Form and Style Manual is available on their website to the public. This manual is the basic textbook for anyone writing an ASTM standard. A study of parts A, B, C, or E on writing test methods, practices, guides, and specifications will show the proper form for the principal types of standards, including a detailed explanation of how to write each section from the title to the appendices. Therefore, if we use the general form for a test method in discussing validation, we will be covering how a test method will look across the technical committees of the society. So again, today's webinar, we're looking strictly at test methods, but many laboratories will find ASTM practices, guides, and specifications just as useful. And many of the tools we discussed today can be applied to any of these standard methods. An ASTM test method is defined by ASTM as a definitive procedure that produces a test result. It goes on to explain that examples of test methods include, but are not limited to, the identification, measurement, and evaluation of one or more qualities, characteristics, or properties. A precision and bias statement is required to be reported at the end of the test method. An ASTM test method typically includes a concise description of an orderly procedure for determining a property or a constituent of a material, an assembly of materials, or a product. The directions for performing the test include all the essential details as to the apparatus, test specimen, procedure, and the calculations needed to achieve satisfactory precision and bias. And it also represents a consensus as to the best current available test procedures for the use intended, and is supported by experience and adequate data obtained through cooperative tests. To be the best current available, test methods need periodic review to determine whether revisions are desirable as the result of technological advances, for example, in manufacturing or testing, or even in use requirements. All ASTM standards require review at a minimum of every 5 years. So listed here on the slide are the mandatory test method sections for all ASTM test methods. There must be a title, a designation, which is an assigned document ID with a revision date, a scope, a significance and use section, a procedure, and a precision and bias section. When applicable, a test method may also give requirements for apparatus, reagents and materials, sampling, calibration and standardization, and conditioning, as well as methods for calculating and interpreting results, reporting, and other requirements that may be necessary for the particular method. Melanie, I think you're going to talk about this next section. I'm going to give the ball back to you.
Thank you, Deanne. We want to define what is validation before we get into validating standard methods. The ISO IEC 17025-2017 standard states that validation is a verification where the specified requirements are adequate for an intended use. As we go through the rest of this webinar, and as you take this information back to your laboratories, please remember the definition of validation and that when we validate, we are looking to assure or verify that the methods we use are adequate for their intended use, that we will be giving valid results and meeting our customer requirements and expectations. To validate any method, a laboratory needs to determine the fitness of the method for the intended use. We do that by evaluating method parameters, understanding the contributions to measurement uncertainty where applicable, and ensuring the validity of results. So how do we do this? Some considerations are bias and precision, robustness, and repeatability and reproducibility. The 17025 standard states in a note entry after clause 7.2.1.3 that international, regional, or national standards or other recognized specifications that contain sufficient and concise information on how to perform laboratory activities do not need to be supplemented or rewritten as internal procedures if these standards are written in a way that they can be used by operating personnel in a laboratory. So if we are using an ASTM test method, when might we need to validate? Again, 17025 states in clause 7.2.2.1 that the laboratory shall validate non-standard methods, laboratory developed methods, and standard methods used outside their intended scope or otherwise modified. And that's the topic of our webinar today, modifying standard methods or using those standard methods outside their intended scope. Outside the intended scope or otherwise modified means that we change that standard method from the intent of the method. Let's look at this for a minute from the point of view of our everyday lives. Deanne, would you like to go over the everyday life example?
Sure, I will do that. Thank you. So let's say you are asked to make a cake using your grandma's favorite buttermilk cake recipe. However, you have no buttermilk and you live in a region where buttermilk is not regularly sold. How do you make a buttermilk cake without buttermilk? Well, a cook's secret, actually one that you can find on Google, is to replace the buttermilk with milk and vinegar or milk and lemon juice. So now you've got the scope of a recipe that says it's a buttermilk cake. You're going to be changing one of the ingredients, takes it outside of the scope. So you need to make a plan. How much milk and vinegar substitute do you need for the buttermilk? You calculate, you modify the plan if you need to, and you ask yourself questions that need to be answered. Will it change the taste? Will it change the texture? Will the people, think customer, enjoy it? Once you've validated the modification of the recipe, most likely by baking the cake with your modification and serving it, you'll have your data. You will be able to modify grandma's cake this way, and people will enjoy it. Let's take a look at grandma's cake in a different way. Again, you've been asked to make the cake. Now, this time you have all of your ingredients, but you do not own a loaf pan. Now you don't have the proper equipment and apparatus. How do you modify this method or recipe? One way you could decide to modify the recipe is by doubling it and putting it in a round pan. You take a plan and calculate the ingredients. Do you need to bake it longer? Well, that will take some experimentation. Does the change in appearance affect how people will perceive it? Will they think it tastes different because it looks different? So you see now that we use method validation in our everyday lives. So now let's go back into our laboratories. What modifications might have to be made to a standard method? Sample preparation, sample matrix, method parameters, instrumentation. There may be others. Note 1, after clause 7.2.2.1 in ISO 17025 cautions that validation can also include procedures for sampling, handling, and transportation of test and calibration items. ISO 17025 uses an example in one of its notes that a measurement procedure ordinarily used for measurement of mass concentration of nitrogen in water may be validated also for measurement of mass concentration of nitrogen in human serum. So let's look specifically back at our ASTM test method model. A laboratory may want to use an ASTM test method outside the method's scope, or they may need to do a modification to the prescribed apparatus, reagents, or materials. The laboratory's sampling method may not match the sampling requirements of a particular method, or a customer may ask for different conditioning or a change in procedure. Any of these modifications or issues would require a validation in accordance with ISO 17025, clause 7.2.2.1. So let's think of a specific example. A laboratory has a non-petroleum organic mixture they need to distill. They routinely distill petroleum products using ASTM D86, which is the standard test method for distillation of petroleum products and liquid fuels at atmospheric pressure. Now they need to use the test method outside the scope, but they have all of the apparatus, they have the materials, and their technicians are already trained on the procedure. So how might the method be validated? ISO 17025, in a note under clause 7.2.2.1, outlines 6 techniques that can be used either individually or in combination. So let's take a quick look at each of these. Calibration or evaluation of bias and precision using reference standards or reference materials. You could do a systematic assessment of factors influencing the result. Test method robustness through variation of controlled parameters. For example, changing incubated temperature or making changes to the volumes dispensed. Comparison of results achieved by other validated methods. The laboratory can conduct interlaboratory comparisons. And finally, an evaluation of measurement uncertainty of the results based on an understanding of the theoretical principles of the method and practical experience of the performance of the sampling or test method. Since ASTM test methods have mandatory precision and bias sections, let's take the time during this webinar to look a little more closely at technique A, calibration or evaluation of bias and precision using reference standards or materials. ASTM defines precision as the closeness of agreement between test results obtained under prescribed conditions. Therefore, the ASTM statement of precision allows users of the test method to assess, in general terms, its usefulness in proposed applications. The statement provides guidelines as to the kind of variability that can be expected between test results when the test method is used by one or more reasonably competent laboratories. Now, this precision statement is not intended to contain values that can be duplicated in every laboratory, but to give statistical guidance as to the variability a laboratory can expect between its test runs or between reasonably competent labs. For those who are interested on how this happens within ASTM, ASTM publishes a practice. It's ASTM E691 entitled Conducting an Interlaboratory Study to Determine the Precision of a Test Method. This can be used by a laboratory or a group of laboratories themselves to create a plan to do an interlaboratory comparison. Also, the form and style manual that we talked about earlier gives all the information you would need to understand how the precision statement in the method can aid you in a modification validation. So let's talk a little bit more about precision. Precision is a statistical examination. And again, to validate precision, we need to look at both repeatability and reproducibility. Repeatability is the difference between successive results obtained by the same operator with the same apparatus and operating conditions and the same test materials. While reproducibility is the difference between two single independent results obtained by different operators in different laboratories, but with identical materials. So let's take a quick look at bias. Bias is defined as a systematic error that contributes to the difference between the mean of a large number of test results and an accepted reference value. The bias statement in the ASTM test method describes the bias and methods to be employed to correct test results. If the bias is not known, but the directions or bounds on the bias or both can be estimated, these are reported in the bias statement as well. So how can you determine bias in your laboratory? By comparison to reference materials, by control charting, and similar QC and trending activities. Here's a visual to help understand precision and bias and the relationship between the two. You can see the unbiased data sits in the middle of this circle or bullseye. In the top two circles, although the average of both sets of data would statistically gravitate towards the bullseye, the precise data has much less scatter than the imprecise data. In statistical terms, if we were to apply metrics to these points, the unbiased and imprecise data would have a higher standard deviation than the unbiased and precise data. But both distributions would center around the population mean or actual value. If you can see at the bottom two circles that again, we have both precise and imprecise data, but it is not centered on the bullseye. It is skewed to one side. Again, if we apply metrics, we'd show a large standard deviation for the imprecise data and a smaller one for the precise data. But the distribution in this case would not be centered on the actual value, but a value that is equal to the magnitude of the bias. So now, having discussed what precision and bias are, let's go back to our example, the laboratory that wants to use ASTM D86 to distill a non-petroleum organic mixture. We see here that the scope of the standard states that it is for the distillation of petroleum products and liquid fuels using a laboratory batch distillation unit. And this will determine quantitatively the boiling range characteristics of products. And it states what type of products: light and middle distillates, automotive spark engine fuels, aviation gasolines, turbine fuels, diesel fuels, biodiesel blends, marine fuels, naphthas, white spirits, kerosenes. It is reasonable for a laboratory to consider that this standard may be good for use of non-petroleum organic mixtures as well. The standard has a precision and bias statement. The laboratory, since it does this standard on a regular basis, we talked about that before, it has the apparatus, it has the trained employees, the laboratory may already be control charting with reference materials, so they may already have available in the laboratory its own precision and bias for the method with no modification. But how were the precision and bias statements for the method developed? How does the laboratory create a plan to validate their modification? In either the scope or under the precision and bias sections of these test methods, there is likely a note That note will discuss the interlaboratory study or studies that were conducted to produce the values in the standard. The note will tell when the study was conducted, how robust the study was, and what parameters were studied. In this case, ASTM D86, this note is discussing the report of 2008 that expanded the test method to include ethanol fuel blends. But if you go deeper into, again, ASTM RRD2 1694 is the reference for that study. And that study will explain what tests and calibrations were carried out and how the data was generated and finally reported. It will show the plan, the data, and the conclusions of the study. This information can be really valuable to the laboratory that wishes to carry out a verification or validation study of its own. Now, I will go on to say that ASTM D86, as you go through the standard and you go through the procedure and then the precision and bias statement, you will find that there are 4 other research reports that are published for this current method. So in 1999, the committee conducted an interlaboratory study that showed how suspended water in hazy samples in certain groups of samples could be removed by a drying agent, anhydrous sodium sulfate, and that this does not statistically affect the results of the test for test method D86. In 2005, the committee conducted another interlaboratory study to establish a bias statement comparing a manual method and automated apparatus and procedures, both of which are covered by D86. In 2007, the committee tested 33 materials by interlaboratory comparison to establish a precision statement for these materials. And finally, in 2012, a small study was conducted to further establish precision statements for various types of petroleum products and liquid fuels. These studies can be invaluable as additional information, as templates for laboratories that need to validate a modification to the method, as they show the plan, the data, the calculations, the robustness, and the conclusions of the validation. Before we finish up this afternoon, let's look briefly at supplementing standard methods. Remember 7.2.2.1 and ISO 17025 states that the validation shall be as extensive as is necessary to meet the needs of the given application or field of application. Here, the laboratory must consider the risk involved with the statement as extensive as necessary. We've been discussing technical modifications to standard methods, but what if the laboratory creates their own work instruction or procedure to assist their technicians? Is there a risk to providing additional details or creating a flow chart? The answer is perhaps. Some validation should occur to make sure that the work instruction, the flow chart, the additional details do not unintentionally change the results from performing the test method. And to review, method validation assists the laboratory in ensuring the validity of their results, determining a method's fitness for intended use, and helps in understanding the contributions of measurement uncertainty when applicable. Standard methods come from many sources, but of course this webinar did use the ASTM test method as a model. Other ASTM methods used by laboratories will include practices, and a practice is a practice may include more than one test method. It may include selection, preparation, application, inspection, necessary precautions for use or disposal, installation, maintenance, and operation of testing apparatus. It may be a cataloging practice, for example, standard practice for receiving, documenting, storing, and retrieving evidence in a forensic science laboratory, for example. Also, there are guides. Guides are also useful sources of information. The purpose of this type of standard is to offer guidance based on a consensus of viewpoints, but not to establish a standard practice to follow in all cases. So, in conclusion, before I give it back to Melanie, is using supplemented or modified standard methods will assist laboratories in meeting requirements of ISO 17025 for the selection and validation of methods. So Melanie, I'm going to give the ball back to you and you can talk about some other resources that we can offer.
Yes, absolutely. Thank you, Deanne, for going over the validation of modified standard methods. We've had a couple questions come through, and we'll get to those after we discuss some additional resources available for laboratories seeking accreditation or those laboratories that are already accredited. This will give you some time to enter your questions into the Q&A box within WebEx. So ANAB offers a lot of different sources of content and information for the conformity assessment community. We have different media to further your understanding of standards, accreditation, management systems, and assessments. On the ANAB website, we have free webcasts that are on a variety of topics. They're between 5 and 20 minutes long, depending on the topic, and they can be viewed at any time. We also have a blog page with a wealth of information related to risk, accreditation, standards requirements, and many others. We also do these webinars monthly. We actually have 2 webinars that we are presenting in April because we have so much information to share. Check out the ANAB website to see our schedule of webinars, as well as to see all of the previous recorded webinars from months starting in March of 2020 through this webinar that will be up in the next couple days. Finally, we offer training in many different areas, including internal auditing, standards, risk, and validation and verification of analytical methods. As with assessments, training changed significantly with the pandemic and those travel restrictions. So most of our traditional in-person courses are still being offered as live online. This gives a little more flexibility in attending those courses because travel is not required. We also have a variety of web-based self-paced training. You can find all of these resources and many more on our website at anab.ansi.org. Now we'll get to, we have additional resources here. We also wanted to provide you 2 resources from ASTM that are really wonderful resources to understand standards and how to select and utilize a standard. So ASTM offers ASTM 101 and ASTM 102. 101 is an introduction to standards, and 102 provides information on selecting and utilizing a standard. Now we'll get to your questions. We have plenty of time to answer your questions. Again, we've only had a couple come through, so if you have any other questions that you want answered, go ahead and enter those in the Q&A box. And if you think of something after the webinar or as you're watching the recording, you can always send those to anab@anab.org. Deanne, the first question that came in, is there a difference in the terms validation and verification?
Yes, yes, there are. Verification is the provision of objective evidence that a given item fulfills specified requirements. So verification points back to requirements. So can your lab meet the requirements of the method that you are choosing? Validation is a verification where the specified requirements are adequate for intended use. Validation points forward to the user. Is this the proper method for the intended use? So again, every validation is a form of verification. And if you can think about that, verification points back to requirements Can we do it? Do we have the apparatus? Do we have the personnel? Do we have the trained personnel? And validation points forward. Is this the standard that my customer needs? Is this going to give me the valid results that I'm expecting? You'll be able to remember the difference between validation and verification. So Melanie, what is the next question is, how does personnel validation play in test method validation?
I can take that one if you'd like.
Okay.
So personnel validation is more so looking at clause 6 of the standard when we look at resources and competency of personnel and authorization of those personnel. So personnel validation is a term used in some industries to say that a person is competent to perform the tasks that are assigned to them and that they're authorized to perform those tasks. So we think taking proficiency testing or doing intra-laboratory comparisons, attending training classes, that sort of thing. So while personnel validation can impact the validity of results, when we're looking at method validation, we're looking more so at the method than the people performing the method. So we're looking at changing those parameters that Deanne talked about, looking at robustness, looking at bias. And then when we look at reproducibility, looking at those different people, we want to use the laboratory personnel that are authorized to perform those methods and those tasks. So while it's kind of ancillary to method validation, it's not typically included in your method validation parameters.
Thank you. Well, that gives me time to read the next question. If we are 17025 and we diverge from a step in the standard, but have validated with one of the methods, would we still pass our 17025 accreditation for that method? I assume all we would need to do is present our data supporting our validation of our alternative process. You would need to show your entire validation process, including your plan and your conclusions. But yes, you would still be able to use the standard method, and it would not it would allow you to be accredited to that standard. Yes. Melody, I don't know if you wanted to say more, but as long as you're doing all of the steps involved in a validation, including giving the conclusion, yes, it would be adequate for your assessor to see.
And I would also just add to that is to check with your accreditation body as well. Check with your accreditation manager if you are accredited by ANAB, but if you're accredited by another accreditation body, definitely look at their policies and rules around modified methods. Yes. And then the next question is the requirements of validation of 17025. Are they included in 15189? So there is a section in specifically the 2022 edition is what they added to their question. There are sections in 15189 for verification of examination methods and validation of examination methods. So you would need to look at those requirements in the 7.3 examination process of 15189. Just skimming it quickly, it does look like it aligns pretty well with 17025, but again, there are different nuances with it being medical laboratories rather than testing laboratories.
The next question that I see, I was able to translate. And yes, this video will be on our website later this week or early next week, and you'll be able to see it as often as you need to. But thank you for asking. Let's see where our next one is.
The next one.
Go ahead, Melanie.
Is it acceptable to apply this approach with other reference methods like standard methods, US EPA?
Yes, it is, as long as you are documenting it, making your plan, and discussing it with your accreditation manager, who again has knowledge of the US EPA standards.
And then is it required to use CRM or is RM sufficient for method validation?
If you were doing control charting with reference materials and you know the value of that reference material, you can use any type of reference material. If you are looking to use a reference material to establish metrological traceability, at that point you do need to use a CRM.
All right, our next question. What are other ways to evaluate the precision other than interlaboratory comparisons?
You can evaluate precision intra-laboratory comparisons. You can evaluate precision within your laboratory by changing apparatus, by changing technicians. That is a very valuable tool to use, especially if you are creating a measurement uncertainty budget as well. So intra-laboratory comparison will help you evaluate the precision of your own laboratory.
Great. The next question, what is the relationship between validation and decision rule?
Well, a decision rule is going to be the way measurement uncertainty is addressed when you state conformity or non-conformity. If something passes and fails, passes or fails, is in or out of tolerance. So again, if you are doing a validation that includes that conformity, if you are doing a validation on a standard where you are going to have to issue a pass or fail statement or an intolerance or out of tolerance statement, at that point you would have to deal with your decision rules.
Okay, the next question. Can you provide insights into the challenges and common pitfalls encountered during the validation of modified standard methods, along with strategies to overcome them? Well, it depends on the laboratory and the method
Go ahead.
that's being,
I had to think about that.
validated. But oftentimes challenges and common pitfalls is not having enough data, not evaluating enough of the parameters, changing enough of the parameters, simply running a reference material or a standard through that modified method and then calling it done, and not really doing an evaluation of repeatability and reproducibility. As far as strategies to overcome them, that would really be dependent on the method that you're modifying and what you are modifying, and the type of data that's being generated in your laboratory. Deanne, do you have anything to add?
Nope. Once I gave it some thought, I would have said very similar.
Okay. The next question, can we use DIN standards, DIN standards, where an ASTM standard is not available? Any type of standard method can be used. We just used ASTM as an example in our webinar today, but if you remember back to one of the first slides that I said, there are many sources of standard methods. So it's up to the laboratory to determine what standard method is appropriate for the measurements that they're performing.
That's right. What I was going to say is it depends on your industry and the industry norms and the needs of your customer. But as Melanie said, the ISO standard does want you to look at international, regional, and national standards or other recognized specifications, and DIN standards meet that requirement.
All right, this next question's right up your alley, Deanne. Are there any specific statistical requirements for the validation, such as sample size, alpha, beta value?
I would not say there are any specific statistical requirements for the validation that I can give you, not knowing what your test method is. But again, you need a sample size that is robust enough that it will give you the statistical data that you need to evaluate whether or not you are still giving valid results. Unfortunately, I can't answer that any better than saying that you need to know the statistical requirements for your own methods. And very often those are written in the methods. They will have been written in your uncertainty budgets. And then you have to take from there and look at what is changing within the method.
Okay, so this
If
next
you
one
have
is,
anything to add to that, that would be fine.
no, I think that was a great answer. Thank you, Deanne. The next question is, what is your opinion on evaluating personnel competence without having validated the method? And can the analysis carried out with the purpose of validating the method be used for the purpose of documenting the competence of the personnel?
I would caution you not to mix personnel competence with validation of methods. Validating of methods is this method proper for the use? Is it going to give me valid results? Is this what my customer needs? Competence of personnel has to do with the training and is more with that back look of verification. Is my laboratory capable of doing this method? Do I have the equipment? Do I have the personnel that are competent to do the test? So it really is two different things. Now, you may, when you are making that change in the method, you may need to add some training for your personnel. And at that point, some training would be in that validation plan. But really, it is two different activities that would be in your laboratory. One is training of personnel, and one is establishing whether or not you can do a method and whether it is the proper method for your customers or clients.
Yes, Deanne, and I would just add, think of in a laboratory design of experiments. If you're changing a lot of variables all at once and one of your variables is the person performing the analysis, it's very difficult to determine if it's due to their competency or if it's due to the method itself. Yeah. So our next question is, we have a non-standard method we use because of how quickly it produces results. Can we run an internal study with standards and interlab comparisons? Can that alternative be acceptable and pass accreditation?
If you have a non-standard method that you use instead of a standard method, and you can also do that standard method, I would do probably an intra-laboratory comparison between the two results that you get from the two, and I would statistically look at it that way, and to see if your alternative is acceptable to your own laboratory. And then I would also discuss it with your accreditation body. But that's what I would do. Definitely an internal study. If you can do a inter-laboratory comparison, that would be great, but you would have to then share your own method with another laboratory to do that.
Okay, so the next question is, which comes first, the validation of the method or the validation of the analyst? That's like the chicken and the egg theory.
No. What comes first is the verification of the method, and then, and with that, the competency of the analyst, and then I would move on to the validation of the method, because your analyst would already be trained to do the method.
Right, so you verify the standard method, make your modifications, or verify the standard method, train your personnel and determine competence, then modify the method, is basically what you're saying, is one avenue that they could take.
Yes. Yes.
Okay, great, great. Well, I'm not seeing any other questions in our chat. I do want to repeat, oh, there's one more that just came in, but I'll finish my sentence. I do want to repeat that this is being recorded, and that recording will be provided on our website as soon as it is available. The question that came through is, can a laboratory finalize an SOP before the method validation is complete? Or must the method validation data be approved first, then SOP?
You do not want to introduce a laboratory written SOP until it is completely validated.
Correct. Yeah. So you don't want to introduce that method until it is validated, and that's what the standard says. I agree with you. Right, well, we do have about 10 minutes till the top of the hour, which is what we had scheduled. So Deanne and I will stay on for a couple more minutes to see if any other questions come in. We are going to continue the recording until all of the questions have been answered, but we appreciate you all coming today. I will leave you with some contact information for ANAB. If you are interested in any information related to our training, you can contact training@anab.org. If you're interested in accreditation, or if you have questions about this webinar or have ideas for future webinars, you can send those to anab@anab.org. And then our web address is there, that anab.ansi.org. Again, thank you all for coming today, and thank you, Deanne, for presenting on method validation of modified standard methods.
Thank you, Melanie, for being with me. I appreciate it.